Hi everyone. So next we are going to talk about the energy conservation approach of the motional EMF by using the Faraday's law. Okay, so as we have seen before, so one thing we know that we have already studied from 11th standard, that is power is equal to force dot F dot V, that is force into velocity. Here force and velocities are both are in the same direction, so cos theta is equal to 1. So power is equal to F into V. So we must have seen this many times. So you must have. So that is P is equal, power is equal to F into V. So now let me tell you something. The total force acting on this portion, this is equal to F, and this is the motional one, and this will be equal to F1. Why? Because there is an equilibrium attained by this particular loop. Okay, so then I get the force acting on the segment. So with current passing through it, F is equal to I into L cross V. So that is also we have studied from magnetic effects of current. So magnetic effects we have seen. So that is the total force acting on a current carrying conductor, that is equal to I into L cross V. Okay, I will be sin theta. So here sin theta is equal to sin 90. So I can write F1 is equal to I into LB. So that F1 is equal to this one. So then I told you, so due to equilibrium, to attain the equilibrium, so we have to write F1, or we have to attain that F1 is equal to F. This one is equal to F, but if they are in the opposite direction, that is why there's minus sign. So you can easily understand the total, the net force, the magnitude of net force is equal to I into LB. But what is I? How much is I? I is equal to E by R, that we have seen in the previous video. So I is equal to BLV divided by R. Okay, so you can substitute the value BLV divided by R into, how much is this one? LB. So I into LB. So I BLV divided by R into LB, that is equal to B square L square V divided by R. So this is the force equation. So in a motional EMF, don't forget this equation. This is very important. Force. And also, what is power? Power is equal to F into V. So substitute the value here. So it will be F into V, B square L square V divided by R into V. So it will be B square L square V square divided by R. You can think like that. B square L square V square divided by R. Okay. So by Joule's heating, so you know that there will be a current passing through it. So there will be a current passing through it. So in which direction will be the current? You can use the right hand thumb rule. I told you right before. So which relation you have to use? Right hand thumb rule. FBI. So it is forces acting in this direction. B is acting in the opposite direction. So the current will be in the upward direction. So I will be in the upward direction. So since there is a current passing through it, so I can write power is equal to I square R. How much is I? BLV by R. The whole square into R. So the power equation is equal to B square L square V square by R. So we have got power equation B square L square V square by R, and also we got it by Joule's heating method, B square L square V square divided by R. What does that mean? Which means whenever you try to move a conductor inside a magnetic field, so one thing you have to be very sure about, that is that the mechanical energy that you are doing here, that will be converted into heat energy. That is why power is equal to B square L square V square by R, and the same power by using the mechanical point of view, that is equal to same B square L square V square divided by R. Okay, so let's see some problems, two problems from the textbook, and then we will discuss next topics. Okay.